Bismillahirrahmanirrahim. Welcome to Diode and Application Season 2, brought to you by EasyLearn. Let's talk about first of all the topics we are going to discuss today. We are going to discuss today photodiode in new topic, and a sensor, basically photodiode, that detects the lights, and data sheet as well as conventional. We are discuss data sheet of photodiode and applications as well as very precisely of the episode in this episode. Okay, first of all, the photodiode. What is photodiode? Photodiode is basically a device that operates in reverse bias. Number one, you can see that this is the symbol, and I am highlighting the symbol, and this is one type of symbol. There are more symbols available for this photodiode, and I will also show another symbol of the photodiode in the upcoming slides. And you can see this is normal, like a normal diode symbol, but there are two arrows that are inside, and it shows that a photodiode. And this is the cathode, and this is anode. This is the anode, and it is connected with negative side of the battery, and it is connected with the positive side of the V bias source, external source. And if in this pattern, definitely it is the reverse bias pattern, and the reverse bias is the normal operating range of region of the photodiode, where I lambda is the reverse light current, and this direction is the electronic current flow, that is from negative to positive. And this is some diagrams. You can see that different types of packing available in the market depends upon the manufacturing company. The photodiode has a small transparent window that is common in among the all designs, that is the transparent window, because it is necessary. Like LEDs, normal LEDs, we are basically want output from the output in the form of light from the normal LEDs. So in this case, it is in contrary to the normal LED. You can just reverse the process. In the normal LED, they emit the light, and here in this case we fall the light on this, and they detect the light when it lights attracts the PN junction, because we want to detect the 100% or accuracy. So we use better glass, transparent glass, so that the maximum light can be detected by the PN junction. So this is at PN junction. You can see that here that very good glass is used, maximum transparency, and this is the Vishay BPW21R visible light silicon photodiode, and you can see that it has this is the anode, and has a little bit longer in length, and this has little bit short, and this is some also has 3 legs as well, some photodiodes, and depends upon the different configurations and shapes as well as different manufacturer designs and our purpose. The photodiode has a small transparent window that allows to strike same last light. And alternative symbols, you can see that it is another symbol. And when reverse bias, a rectifier diode has a very small reverse current. We are talking about the normal PN junction diode. This is the rectifier diode, and this has when we are connected in the reverse bias, in the practical case, there is a very small reverse current. For example, okay, I cannot draw here. Has a very small reverse current, leakage current, that is called leakage current. But in ideal case, there is no leakage current, there is zero current, reverse current. The same is true for the photodiode. Okay, same case is in the photodiode. There is also a reverse current, but it is produced by thermally generated electron-hole pair in the depletion region. Okay, that this thermally generation in the normal diode. In case of the normal rectifier diode, when we had connected the positive side with the cathode, and anode is connected with the negative side of the V bias, it is called the reverse bias of the rectifier diode. Then if there is a little bit current in the reverse bias region, it is called the reverse leakage current. But here in this case, reverse leakage current is produced when light falls. You can see these are the photons. For example, if I can zoom this, yes, this is the normal diode, and this is the depletion region. This is the boundary of the depletion region or intrinsic region. Here you can see that this is the negative, and these are the negative electrons here in this orange shade, and these are the positive, shows that these are the holes. And when these electron and hole pair wants to cross this depletion region, basically they need energy, and we provide this energy in the form of the photons. External light, when we fall light, it detects light is a form of energy, basically energizing them to cross the depletion region, and electrons flow is towards the positive, or positive attracts these electrons to its positive terminal, and negative towards negative, holes are attracts towards positive, negative. While in the normal case of the p-n rectifier diode, basically this energy is provided by the thermally, and you can say that when we rise the temperature, we are providing the energy in the form of heat. So when temperature is increased, reverse current is increased. But here in this case, when these externally photons or light intensity is increased, our reverse current is increased. So this is the theory what I have already explained. In the rectifier diode, the reverse leakage current is increased with the temperature due to an increase in the number of the electron hole pair. But a photodiode differs from the rectifier diode in that when its p-n junction is exposed to light, this is the change. Here it is temperature, and here in this case it's light. The reverse current increases with the light intensity. And what is dark current? When there is no light, when there is no incident light, the reverse current is almost negligible. But here in ideal case we can say it's zero. When there is no light, reverse current is zero. When there is light is increased, current is also increased. But when there is no light, in practical case, there is always small leakage current. That is called dark current when intensity of the light is zero. Here you can see that when the light intensity is zero, this graph here zero, this curve basically is not zero. There is little bit reverse current, and that is why I have shared that this at this point when the light intensity E is zero, and there is also some reverse current, we can say that this is the there is small leakage current, and this is called irradiance. Intensity is also called irradiance, and it is represented by milliwatt per centimeter square. And if an increase in the amount of light intensity called irradiance produces an increase in the reverse current, and this is graph, and when irradiance is increased, reverse current is increased in almost linear graph. Here also reverse voltage versus reverse current in microampere, when you can see that for example when 10 reverse volts, there is 1.4 microampere current at 0.5 intensity. But when intensity is increased, same for the case of the 10 volt, when in only intensity is increased, current is increased 2.5. But again when on 10 volts, and if intensity is light intensity is increased, then what happens, you can see that irradiance, due to the irradiance means intensity of the light, current is increasing. And I will also try to calculate here. You can see that we can calculate the resistance of these curve. For example, here on this 10 volt, the first curve, this is 10 volt from Ohm's law, R is equals to V over I lambda. Here 10 volt divided by 1.4 here. When the irradiance is 0.5, its resistance is 7.14 mega ohm. And for this last curve, let's say on all the parameters are same, voltage is same at 10 volt reverse voltage. Our irradiance, our current is 55 microampere. Here you can see that this is 55 microampere, and irradiance is increased, everything is same, then resistance is decreased. So from previous here you can see that this is 7.14 mega ohm, large resistance in case of low in light intensity. But when light intensity is increased, resistance is decreased. So we can also control the resistance from this. You can see that when light is off, there is no reverse current on the ammeter, but when light is fall, there is a reverse current. So this is for silicon material, the electromagnetic spectrum wavelength range is 190 to 1100 nanometer, and for germanium this is 400 to 1700 nanometer, and it also change from material to material. So this is the diode data sheet. From here we can also see that there are different type of absolute maximum ratings available. This, for example, this is the 25 degree C. Here you can see that unless otherwise specified, reverse voltage is 60 volt maximum, and power dissipation at less than 25 or 25 volt is 75 milliwatt. And this is the 100 junction temperature, and this is the soldering temperature, normal storage temperature. And here, but operating temperature maximum is 85. Please note it is 85 operation while we are trying to operate, because above 85 its specification is changed, and we cannot use its waste and useless material. Okay, for forward voltage is same, reverse breakdown voltage you can read by yourself. But here reverse dark current means, we already studied, when there is no light intensity, means to say E is 0, but they at 10 volt you can see that there is 10 nano, very less, but there is a current in practical cases. So this shows that dark current. Diode capacitance and reverse light current you can read by yourself. The light it has some characters that benefits, you can say that these are the benefits and of this photodiode. The linearity, that is very big benefit. That is it has linearity in its graph of its diode. Linearity graph I had shown in the starting slides. Noise is also low, response is wide spectral, light weight and compact, long life. And these are the some applications. Smoke detection, we use these, compact displays, televisions, remote controls, and in mobile phones as well. Also in nowadays you can you see that in mobile phones for brightness control there is an auto brightness function. Auto brightness basically can be controlled by using photodiodes as well. Used for an exact measurement of the intensity of the light in the science and industry. This is very important application, but they have an enhanced, more linear response. Once again we are using the linear characteristic because than the photoconductors. These are the another device that is photoconductor, but we had not discussed right now photoconductors. So but have a much better and enhanced response due to linear characteristics of the photodiodes. Widely used in the numerous medical applications. Of course, medical applications, they are very vital role in instruments to analyze samples. These diodes are much faster, okay, and more complex. As they are faster, but they are complex than normal p-n junction diodes, and hence frequently used for lightning regulation and optical communication. So we will discuss next time laser diode, but for right now it's finally over. Lecture is over now, and we will discuss laser diode next time.